Okay. Let me just make sure it's recorded. Okay. So if you know, just generally, if you know in a triangle, do, 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 baby shark, do, 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 do. Actually, I was asked to leave Windermere Prep just because of my weirdness. It's a little known fact. Okay, so there we go. What your surveyor can do is set up their thingamajig, right?
Right.
And they're gonna stand here with their thingamajig, and they're gonna have to come to practice, or they're gonna have to give you their thingamajig. Somehow you're gonna have to get that, or you're gonna have to make your own. And I'll talk about that in a second. Okay. And they will be able to tell you this angle to the top, either to their hand, whatever. You decide what you want to be at the highest point, the head, their hand, whatever. They can tell you this angle, right? Tater. You can measure the distance from here to here using a tape measure. So the centering on the head as best you can, or whatever. Right? So yeah, that's going to matter where you're, whatever. You'll figure, are you following me? It has to be as close to right beneath your flyer as possible. Okay. So if you have this, I don't know, let's say it's 15 feet. Like from here to here is 15 feet, right?
Right.
And that means from here to here is 15 feet. Can't you find this value? We'll call it X.
Yes.
Which trig function? Test.
Opposite adjacent. So tan.
There you go. So tan theta equals X over 15, and then you can figure it out, right?
Right.
And you can figure the height. Now you're finding this. Is that how high off the ground the person is?
No.
No. What else do we have to do?
You have to do the little part. Oh,
The
you can
height
do.
of, you have to add the height of the thingy wingy,
Okay.
right?
Right.
Okay, so then what you can do is do different combinations of holders and flyers, as many as you can, to figure out which one gives you the greatest height.
Okay.
And then you're doing real world data. They love that crap when you do real world data. Okay. You want to talk about what could cause errors. You want to talk about how you could improve on that, correct that, what went right, what went wrong, that sort of nonsense. And if you really want to get like an awesome score, and this isn't hard, the mathematics is not hard, and that's actually kind of fun, isn't it?
Yeah.
Once you find yourself, you know who would be, if you can't get a surveyor, I just thought, you know who you could get pretty easily?
True.
A firefighter. They could bring their fire truck, pull it right up, get that ladder and put it up there. Drop themselves a measuring tape. That was pretty good. You bought it totally. I like.
Oh, I was still believing it. I was like, okay. I thought you were serious. Okay.
Okay. Now, this would be awesome because the surveyor. Oh, okay. The surveyor is going to be able to tell you almost exactly how high the person is,
Okay.
just from their instrument, right?
Right.
So you could compare the surveyor's, the exact height to your estimated height as well.
Okay.
You want to wrap all of this in and make it a nice paper. Are you a good writer?
Yes.
Okay, then it'll write, it won't even seem like it's, I'm actually excited about it. I might come watch the whole thing. That's how sad my life is. I don't know what I'm saying. Okay, so here's the other thing that you could do. You can make your own angle thingy, a sextant type thing. Homemade sextant. What? Because it says sex. Is that what? Is that why you were laughing? Is that it?
I didn't know. So I forgot that somebody would have made that.
What are you talking about?
Like somebody made a sextant. Like I didn't think about. I think they like appear. Like I don't think about like, oh, somebody made like Powerade. I'm looking
What?
at. No, I'm like looking at it. Like somebody made this. Like I don't think about it like that. You know?
No, I don't. I'm not sure that I want to.
What Alexander Graham Bell like made the telephone? Like I don't think like, oh, like yeah, somebody like made the telephone. Like I don't think like that. Until,
What do you just not think about it? Do you think
yeah,
that they were always here?
I just like don't realize that people made them. I kind of like I don't think about it, but when I do, I guess I like think that it's just always been here. Right.
Nothing to say. I don't know what
Sorry,
to tell you.
that was my little tangent. Taz. Okay.
Is that Denton?
No, that's my dog.
Listen, did you hear what you just said?
What?
You just said that after you started talking about how you don't know, like you don't think about things,
Yeah.
right? Or where they came from. You said, that's just my little.
Tangent. Yeah.
All right, so this is a homemade sextant. So can you see how if it was straight up and down, so this is a string tied the center of it. Do you know what this is? We don't use these anymore. Yeah. So if you're holding it straight, it's going to go straight down and it's going to be right at 90 degrees, right?
Right.
So if you tilt it, you take 90 minus whatever, and you get your angle of you get the angle, right?
Right.
So that's three different ways you could be calculating the height. One, using the surveyor, like the exact or almost exact. He'll tell you it's exact, or she, that was sexist. I'm so sorry. We'll tell you it's exact. Then you can do your measurements and your calculations, and you could, try and do it this way and see how close you are.
Okay.
And then the little straw is like your little telescope so your eyes, like it's aimed right at the top of the flyer's head or whatever you want to measure.
Okay.
How's that sound?
Sounds good. Yeah.
Yeah, and Macintosh is going to go, oh, that's stupid. Becker has lost it. She's going to roll her eyes. You know what? She's one of those people who she can't hide what she's feeling. Like her face says it all. Like she has zero ability to hide how she feels about something, which is awesome.
She said something to me yesterday and I was like, what? And she was like laughing. I was like, oh yeah. I can't even remember. It was something about my math. She's like, oh, it's like really helping, like saying you're really helping. I was like, yeah. And I said something. She's like, yeah. And she like was talking about something. And I was like, what did you just say? Like, what? And like, yeah.
I didn't follow that at all, but it sounded funny.
Yeah.
There was a whole lot of likes. That was a record number of likes within a
I
15
know.
seconds period. You're not bad. Actually, you're not bad
Huh?
at all, because I'd be hammering you if you were a like person.
Oh, no,
So you're not bad. Okay, so are we good? Like you can answer the freaking Macintosh questions and whatnot?
I think so.
Okay. Because I would think it would be best to be as high as possible on your stunts. That's the point, right? To get them up there and smoking the weed and stuff. That's what you could add. You could do it, get as high as possible in two different ways. You could measure the degree of highness of the sixth grader, and you wouldn't have to finish your IA because you would be expelled. So you would have that too.
Win-win.
Maybe even go to juvie. You could go to juvie school.
That sounds fun though.
I think you would do really well there.
Oh, that was so sarcastic. I
You
love
could
it.
start a juvie cheerleading squad.
Oh no.
Okay, so have you got some questions for me? Some mathy. I heard something about rational functions and horizontal asymptotes.
I did talk to her about that. I thought,
But you don't have any questions, correct?
yeah, she said she would send you stuff.
She just sent me topics. She shouldn't, by the way, she's going way above and beyond for you.
She
Like
is.
every week she sends me like,
Because I go in during LLT and I'm like, I have tutoring today. What should
you
I
are,
do?
and do you do the head tilt and the smile
I do.
like that?
She loves me. I used to rant to her like sophomore year, even last year. I'd just sit in class and be like, okay, I need to tell you all my problems.
Oh, so did your problems rhyme with trick or sick or?
No.
I actually like he was let's not bang on Nick. It's not awful, is he?
No,
choose not to.
His mom is super sweet. He was nice, and then he made some comments about me. So.
Oh, well, that's not nice. Okay.
Yeah.
No, boo. Nope. Unacceptable. All right, ready?
Yes.
Okay. The internet is an amazing thing. So here's the deal. Rational functions are a polynomial over a polynomial. Does that make any sense to you? What I just said.
Isn't a polynomial like no? It's like in the group of like exponentials and
No,
like,
it's not. Polynomial is like x squared plus 2x plus 7.
oh.
Those guys, or 3x plus 1, or 5x cubed.
Okay.
Those are polynomials.
Okay.
And rational functions, tell me about those.
That's that little chart we do, the irrational and rational. It's
No,
like,
that would be it's actually a whole different thing. That would be the real number system. Rational numbers, irrational numbers, real numbers, integers, that. Yeah, that's, well, I suppose. Okay. Rational are written that look like fractions.
oh,
Rational functions. So I take it back. They are related, but not the way you were thinking.
oh.
I apologize.
I made
Okay.
a real world connection.
So I don't know, 3x squared plus 2x plus 7 is an example. Like, I don't know, 10x to the 5th minus 2x squared plus 3x, right? 5x minus 2. We can go on and on and on, want to. I think we should do another one. So we could have 4x squared minus 3x to the 5th plus 7x cubed, minus 2x to the 6, what else? Right?
Right.
Okay. So we're going to talk about the degree of each of these polynomials. Does that ring a bell?
No.
The degree of a polynomial is the number that is the greatest exponent.
Oh.
So this is a second degree, fifth degree. What degree is this polynomial?
The first degree.
Yay. What about this one?
The sixth degree.
Right. And 3 of these polynomials are written in standard form, and one of them is not. Do you know which one is not written in standard form?
I know the first one is standard form.
Okay.
And then I guess the last one, because it's not in descending order.
Oh, yay, Ashlyn. You said descending. Very good. So in standard form, this would be negative 2x to the 6 minus 3x to the 5th plus 7x cubed. Oh my God, plus 4x squared. I'm going to write one more as, let's see, x cubed plus 2x plus 7, whatever. So there's another one. Okay. So second degree, fifth degree, first degree, sixth degree, third degree. Yes.
Yes.
So there's also something called the leading coefficient. The leading coefficient is the coefficient of the term that has the greatest degree or the greatest exponent. So what is the leading coefficient of our first one?
3.
Second one?
10.
Third?
5.
Fourth?
4.
Fourth?
Oh, -2. Oh, 7.
Yes, -2. I was shaking my head that you said 4.
Oh.
That was making me upset because we went through the whole thing.
I
of
looked at the
standard.
wrong one.
Well, even so, Ashlyn, and I'm trying not to yell and say bad words.
Okay.
We discussed that it would be the coefficient of the greatest
Yeah.
exponent. Okay. See, aren't you proud of me how I kept my calm? And what about this last one? What's the leading coefficient?
1.
Very good. So general form of a coefficient, I'm sorry, of a polynomial could be like ax to the m power plus blah, 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 blah. Yes?
Yes.
Or bx to the n power plus blah, 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 blah. Let's just assume that in these two polynomials, m and n are the greatest degrees because we're writing them in standard form. Because if we're going to generalize it, we would write them in standard form. So yes?
Yes.
So what would the leading coefficient be of this guy?
A.
Good. And this guy?
B.
Okay. So I'm going to throw those in there. Here, we're going to have in the top of our rational function, like it just could be here, we'll do one of these. So 3x squared plus 2x plus 7. Okay. And then, I don't know, pick one. Last one. Good. X cubed plus 2x. Wow, lots of 2x's plus 7. Okay. So you got all that.
Yes.
And then we're going to say g of x is equal to ax to the m plus da 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 da. And then we're going to have bx to the n plus da 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 da. Okay. There's 3 possibilities for a horizontal asymptote. Okay. And it all depends on the degrees of the degrees of the polynomial or the greatest exponents. Yes.
Yeah.
And we've already said that m and n are the m is winning in the numerator and n is the winner in the denominator. Okay. Ready? This is exciting. If m is greater than n, there is no horizontal asymptote. If m is less than n, the horizontal asymptote is y equals 0. Okay.
Okay.
What's the only other possibility?
If they're equal.
Ha ha ha. If m equals n, then, or I should say the, to be consistent, the ha, do you see what I did there?
Yeah.
Ha instead of horizontal asymptote. Did you make that connection?
I did.
I'm not laughing, to be
Okay.
clear.
No.
Is y equals a over b.
Oh,
Okay.
okay.
That's sort of a lot to kind of memorize. So maybe we should think about it. And we talked about this last time, or one of our times, about x going to infinity. Do you remember that?
I think
A little
so.
bit.
A little bit, yeah.
All right. So for this one, looking at our rules, tell me about the horizontal asymptote.
M is less than n, so y is going to equal 0.
Excellent. Okay. Now, y, not get it because they sound, okay. Those are homophones. Okay.
It's a big SAT word.
Yes, the SAT. Always thinking that Ashlyn Loper.
I've said that for years.
What?
The
Homophone?
no, when somebody says like a big word, I'm like, oh, that's a big SAT word. 'Cause I don't.
That's a good joke. That's good. I mean, it's no a priest, rabbit, and minister walk into a bar joke, but it's good. It's good,
Yeah.
Ashlyn. Don't give up on it. Don't give up on it.
Yeah.
All right. So this is why this works. Okay.
Okay.
Well, horizontal asymptote. Dude. Dude. I'm sorry about that. That's just awful. Right? And we'll go green.
Right.
And it's like this thing, right? And it goes on and on and on forever. And this is some function f of x, right? Yes.
Yeah.
Okay. And it goes forever. Am I right?
Yeah.
Like forever and ever and ever and ever and ever and ever and ever. So as this function is going out here, to calculate the y value, the x values are getting larger and larger and larger and larger and larger and larger and larger, aren't they? And where are those x values going, young lady?
Infinity.
Where are they? Infinity and beyond. Oh, that's a different thing. Infinity. It's not possible to go beyond. Anyway, to infinity, right?
Right.
Point being, they're getting incredibly large, aren't they? Yes. So if we go back to this function, yes,
Yes.
we go back to this function as x gets incredibly large, right? Like, well, let's just start with 1. Let's let x be 1. Okay.
Okay.
So if x is 1, then this guy is 3 plus 2 plus 7, right?
Mhm.
If x is 10, this is going to be 300 plus 20 plus 7, isn't it? 10 squared is 100 times 3 is 300.
Oh, yeah, sorry.
Okay. If X is 100, what's 100 squared?
1,000.
10,000.
5, 10,000.
So if X is 100, right? So this was X equals 1. This is X equals 10. X equals 100. It's 10,000, right? And 3 times
So
10,000
30,000.
is 30,000 plus 200 plus 7. Do you see how these guys are becoming less and less significant
Yes.
compared to the dude who's getting squared,
Mhm.
right?
Right.
Okay. So with horizontal asymptotes, these loser terms that aren't the have the greatest degree don't matter because of this. This is what happens as X goes to infinity or negative infinity. Doesn't matter which way. You okay?
Mhm.
Okay. So that means when we're thinking about our horizontal asymptote, that's why we only consider these terms, 3x squared over x cubed, right? So let's do this little fun thing again. When x equals 1, we have 3 over 1, right?
Right.
X equals 10, we have 300 over 1,000. Yes?
Yes.
X equals 100, we have 30,000 over, there's going to be 6 0, a million. 1, 2, 3, 4, 5, 6, over a million. So do you see what's happening?
Yeah.
The cube is kicking the crap out of the square.
Mm.
Yes. So I'm getting something really, really small compared to the denominator, aren't I?
Yes.
And if I take something small divided by something big, what's that trending towards?
Really small. Negative infinity.
No, it's
0.
0. 0. That's why this is true. If m is less than n, the horizontal asymptote is y equals 0 because of this. Because infinity cubed compared to infinity squared is there's no competition. The cube, look at that. We only went to 100. Look how far it went. Isn't that amazing?
Mhm.
You're patronizing me. You are patronizing me. Okay, so now 1, 2, let's do f of x equals x to the 5th plus 2x to the 4th plus 957 x cubed over 10,000 x to the 4th plus 7. I don't know.
Okay.
Okay.
So
So
5,
what's driving the bus? Or actually, tell me about the horizontal asymptote according to our rules.
there is none.
No. Can you tell me why? Don't say because m is greater than n.
Well, that is true, but it's because 1 will never be 10,000. It'll be really small, but it's like going to be a negative number, maybe. Yeah.
No. Like
Okay.
if x equals 1, when x equals, like we're done with, we're only talking about x to the 5th over 10,000 x to the 4th.
Yeah.
Yes.
Yeah.
When x equals 1, we would have 1 over 10,000. Is that fair?
Yes.
When x equals 10, now watch this. This is amazing. So That's gonna add 4 more zeros to 10,000 because 10 times 10, there's gonna be 4 zeros, right?
Right.
Yes. So 10, 1, 2, 3, 1, 2, 3, 4. Okay. Bonk. Bonk. 100 million. 10 to the 5th, there's gonna be 5 zeros. 1, 1, 2, 3, 4, 5. Right? Yeah.
Right.
Yep. Right. Okay. 1, 2. Actually, I have too many. Oh, no, I don't. Okay. So to the 6th, I'm sorry, if we have, if X equal, oh, no. This was 10, right? Okay, I'm sorry. Now, if we do 100, okay, this is gonna generate 10 zeros. The long story short, eventually X to the 5th is gonna kick the crap out of X to the 4th, even with the 10,000.
Okay.
Right? Because it's to the 5th power.
Mhm.
Right? Meaning I'm gonna have a giant number. Okay, compared to a smaller number. So if you have a really big number divided by a really small number, you get a really big number, don't you?
Yeah.
And it keeps growing and growing and growing and growing. It goes to infinity. Okay. And if it goes to infinity, the graph is going to infinity, there's no horizontal asymptote. Okay. So that's why this first one is true. Whoops. Did you hear the spooky thing?
Yeah.
It's our Halloween clock.
Oh.
It's our holiday clock.
Oh.
Yeah, there's music for all the holidays except for Thanksgiving
Oh.
and my birthday. So if f of x equals x to the 6 plus 7x squared minus 12 over 5x to the 6 minus 7x cubed plus 83x, what's the asymptote? Horizontal
Y
asymptote.
A over B.
Okay, which is what?
1/5.
Very good. And that's because we're only considering x to the 6 over 5x to the 6. These cancel out. Same thing. 1 over 5. Okay.
Okay.
So I just want you to look, see if you remember. I'm going to share. Oh, it has the answers. Too bad. Okay, here we go. It's going to be exciting. Can you read that? The function?
It's not up there yet. Yes.
Oh, I have to click it. That's weird. All right, what's the horizontal asymptote?
It's 4 over 1, 4.
Please say y equals 4.
Oh, y equals 4.
Very good. This one. Is it really big over really small or really small over really big?
I can't see it.
You really can't see it
No.
at all?
No, that's why I was moving my head weird. Oh my gosh, I thought it was the same one. Sorry. So big.
Wait, hold on. Is that good? Wait, no, wait, no, I got you. Hold on.
Oh,
Is that good?
that's great. So
Okay.
2 over 1, so m is greater than n. That was
I
the
don't want you
first
to think like that. I don't want you to think like that.
2m over
You have
n.
x squared over x, right?
Yeah. Oh, they
So
just cancel out.
is it really, no, is it really big over really small? Or really small over really big?
Really big over really small.
What's really big divided by really small?
Um, infinity. No.
So,
Oh yeah.
yes,
So
yes.
it's
So none,
none.
there isn't one. Can you see it?
Yes. So this is really small over really big. So it's gonna be 0. Y equals 0.
You're darn right. Okay. Okay, this is your big test, then we're done.
Okay.
Number 1,
Number 1. Oh, there we go. Really big over really small. So that's infinity. So y equals none.
none. You don't say y equals none.
Oh, you said y equal. Okay, so none.
Please on the test write y equals none and see what Macintosh does. See if she takes off any points.
I probably have written it on there and she'll give me pity points.
Oh, please do it. I just can't wait. I mean, who cares, right? It's just a
Yeah.
grade.
She knows what I'm talking about.
Okay, number 2, what is it?
Oh, they're equal. So 7 over 1 is y equals 7.
Number 3,
Oh, it's the same thing. 3 over 2, which is 3 halves, or y equals 1.5.
look at you. Fractions, decimals, she don't care. She converting. What? Number 4,
Okay, so small over big. So that's 0. Y equals 0.
y equals 0. Good.
And then, oh, it's equal again. So 8 over 4 is 2. Y equals 2.
Look at you. Do you think you have it?
I think so.
You know what's awesome?
What?
Look. Oh, I didn't put it up there. I'm sorry. I'm looking at the sheet I had. I thought I put it on there. I didn't realize it, but here, I'll do it again. I thought maybe I had put this up there for you. Is the new one up there yet?
No.
Yes, it is.
Oh.
The answers are right.
Oh.
I thought I'd given you that, but I hadn't. That would have been great. Look, it doesn't say y equals none.
Yeah. So you knew I didn't cheat.
All right, got it?
Yes.
Horizontal asymptotes are freaking easy. They're actually easier than vertical asymptotes. If you just think about it just a little bit. Okay? All right, I'll send you the notes. And oh my God, this video is massive. So it has to process, blah, blah, blah. I'll send you the link.
Okay. Thank you.
All right. Any questions?
Nope.
And you have a big giant fall vacation.
Yes.
And you're going to you're going to Young Miss or Mrs. Miss?
Yeah, Old Miss or Young Miss. Yeah.
Miss the 6th grader coming down and she died. Old Miss, that kind of miss.
University.
You didn't
Miss.
think that was funny. You didn't think that was funny. That's not funny. You don't want to drop the 6th grader.
No. Oh, I don't want to listen to them complain. That's on video. That's on video. Oh my God.
Oh, I'm dying. Well, just cut. Okay, you've had a good run. Stop complaining. You've had a good life.
You should have done what you're supposed to. You should have squeezed your butt in the air.
Oh, thank you for that. Thanks for that. Like I needed to know that.
No, I get mad at them. They don't know their rights from their lefts. Like, oh, I can't. That's a whole nother tangent.
So when you weren't born and President Bush was president, George
think
W.
Yeah.
Yeah, you were alive.
2003.
Yeah. Yeah, okay, I take it back. George W.
Mhm.
The comedians made jokes that he wasn't all that smart, but he really is. But he wasn't. But but he would say things like instead of good strategy, one time he says, "That's good strategery."
Oh.
Okay, and hold up your right hand.
Well,
Okay.
it's for you, but yeah.
Okay, is this no? Yeah, but for you it's not. Is this my right hand?
Yeah.
Okay. So one time Bush is giving a speech and or just like answering questions, and he says, "Now the problem is the right hand doesn't know what the left hand is doing." You know the saying, the right hand doesn't know what the left hand is doing.
I probably heard it, but I don't understand it because it knows,
The
knows.
right hand doesn't know what the left hand is doing. This is my left hand. The right hand doesn't know what the
Oh,
left hand is doing.
I have seen that. Yeah.
It was hilarious. And the poor guy, it's an easy mistake, but he's a president, so everyone's going to kill him. Everybody. That goes with the territory. Okay. Now that you're laughing hysterically, I have one more joke and I'll let you go.
Okay.
Did you hear about the Mexican magician?
No.
He's doing a trick and he's going to make a rabbit disappear. Not the rabbit that went in the bar, because
Okay.
it was a different rabbit, different thing.
Okay.
Right? And
Right.
so the Mexican magician says, "I'm going to make the rabbit disappear. Unos, dos, poof." The rabbit disappeared without a trace.
That's a good. I'm so happy I took Espanol Uno.
Works both ways, doesn't it?
Yeah.
It's fantastic, no matter what. Right?
Right.
TRACE, it works.
Oh.
TRES.
Mhm.
Is that how you spell trace in Spanish?
I hope so.
It works.
Yeah.
What's the goal? Oh my God, do not go to press in Mississippi. I don't
Oh,
care what kind of baseball player dad was.
I'll meet my Uncle Brian.
Oh,
Oh, good, they're
Uncle
not.
Brian, Uncle Brian did some time, did he?
Oh, he's probably doing it right now. He like,
He's making license plates.
yeah, he likes the weed, or he likes the harder stuff. But I've never met him, so
You've never met him. You've heard tell.
yes, my mom's never even met him. Sorry, I'm telling you my whole life today. You
Oh,
probably don't.
and you know what? The great thing is, this is being recorded, and I'm throwing it up on the internet pretty soon on my YouTube channel.
Oh, oh.
Bye, Ashlyn. Be good.
Thank you.
All right. Bye.
Bye.